If a series is convergent by the integral test, how do you estimate its sum? The sum S can be estimated by the inequality S sub n plus the integral from n plus 1 to infinity of f of x dx is less than or equal to S, which is less than or equal to S sub n plus the integral from n to infinity of f of x dx, where S sub n is the nth partial sum. If a series is convergent by the comparison test, how do you estimate its sum? We first estimate the remainder for the comparison series. This gives an upper bound for the remainder of the original series, as in example 11.4.5. If a series is convergent by the alternating series test, how do you estimate its sum? We can use a partial sum S sub n of an alternating series as an approximation to the total sum. If the size of the error is guaranteed to be no more than the absolute value of a sub n plus 1, the absolute value of the first neglected term. Write a general form of a power series. A power series centered at A is the sum from n equals 0 to infinity of c sub n open x minus a closed to the power n. What is the radius of convergence of a power series? Given the power series, the sum from n equals 0 to infinity of c sub n open x minus a closed to the power n, the radius of convergence is number 1, 0 if the series converges only when x equals a. Number 2, infinity if the series converges for all x. Or number 3, a positive number, big R, such that the series converges if the absolute value of x minus a is less than big R, and diverges if the absolute value of x minus a is greater than big R. What is the interval of convergence of a power series? The interval of convergence of a power series is the interval that consists of all values of x for which the series converges. Corresponding to the cases in part B, the interval of convergence is number 1, the single point open curly bracket a close curly bracket. Number 2, the interval from negative infinity to infinity. Or number 3, an interval with endpoints a minus big R and a plus big R that can contain neither, either, or both of the endpoints. Suppose f of x is the sum of a power series with radius of convergence big R. How do you differentiate f? What is the radius of convergence of the series for f prime? If f of x equals the sum from n equals 0 to infinity of c sub n open x minus a closed to the power n, then f prime of x equals the sum from n equals 1 to infinity of n times c sub n open x minus a closed to the power n minus 1 with the radius of convergence big R. How do you integrate f? What is the radius of convergence of the series for the integral of f of x dx? The integral of f of x dx equals big C plus the sum from n equals 0 to infinity of C sub n times open x minus a closed to the power n plus 1 over n plus 1 with the radius of convergence big R. Write an expression for the nth degree Taylor polynomial of f centered at a. Big T sub n open x close equals the sum from I equals 0 to n of the ith derivative of f of a over I factorial times open x minus a closed to the power I. Write an expression for the Taylor series of f centered at a. The sum from n equals 0 to infinity of the nth derivative of f of a over n factorial open times open x minus a closed to the power n. Write an expression for the Maclaurin series of f. The sum from n equals 0 to infinity of the nth derivative of f of 0 over n factorial times x to the power n, open bracket, a equals 0 and part b, close bracket.